And welcome back to the channel. In this episode we are looking at putting the front differential back together. Now I have obviously painted the housing, and I'm just now using a bit of can air just to ensure we've got no debris left over, and now I'm just going to clear the original bearings. Yes, we are reusing the pinion bearings. Unfortunately the kit didn't come with the pinion bearings or the pinion seal. I would have to replace the seal anyway because it is over 24 years old. The rubber was starting to harden. It would have only a matter of time for it to stop leaking. But being a part-time four drive, with probably 98% of the time, that front diff's not turning. It is sitting there unused because the vehicle is fitted with freewheeling hubs and the like. Now, so these bearings are still practically brand new, as well as the pinion and ring gear. So it is practically safe. I'm just making sure it's nice and clean. Another thing the kit didn't come with is the pinion spacer. Now, after discussion with a few people, ideally it would have been best to actually replace it, but with a little bit extra preload you can probably get away with it. Now ideally I would have replaced the bearings as well, because we've got two new bearings for the center but just not for the pinion, and the reason that is because you would have had to press the old bearings off the original center, which would have damaged them at some point. So I'm just cleaning up the end caps. Now they're generally machined with the caps installed, so the caps are actually handed for each side. So during disassembly I would mark them. So one side's got a double mark and the other side only a single mark with a punch. So I'm just making sure that I install the caps on the correct side. Now this is important because they will not line up, nor would the threads line up correctly. Now, if for something you've never done before, it is always good practice to have a manual on hand and spend some time looking at it. Now, a lot of aftermarket manuals sometimes lack a lot of information. For instance, I didn't have much information on regarding rebuilding or disassembling or reassembling the actual differential itself. And at some places I had to hop online and Google for very specific information, and even then it was still in most times lacking, in one better sense of the word. Now this video is sped up a fair bit because this process did take some hours. As you see, I'm now looking through the actual supplied manual for the e-locker. Now again, normally you would not remove the pinion like I have. Like I said, I'll just remove it for ease of painting and cleaning, as well as drilling the hole required for the activation wire. You're able to clean out the housing properly, ensure there's no debris left over. So again, I'll just make sure there's no dust and dirt in the bearing. And because the diff was not going to have any oil in it anytime soon, I made sure that all the bearing surfaces had some sort of lubrication, hence the assembly lube I'm using. So when the diff goes back in the housing and the housing goes back into the car, it will get oil, but not for a while. So now I'm just making an improvised stand to install the pinion. Now the pinion does actually sit a lot higher than the actual mounting surface, so I had to make a improvised support system for the pinion. Now the carbo wasn't necessarily cooperative initially, but it did actually work, and it worked well. So I needed to hold the pinion right up to where it would normally be sitting. Then I realised I need the pinion spacer on first. Put that on. Bit of lubrication, make sure it's clean. Bit of lubrication. because being a top pinion diff, it does actually need rotation of the differential itself to actually sling oil up in. Now the bearing is tight on the shaft, so I had to just gently coerce it down on the shaft. I found that using the actual flange was a lot quicker and a lot nicer. Does look a bit barbaric with a hammer on it. Now, since I can get the nut on, I'll just use the nut to actually pull the bearing all the way down. Still a little way to go. Now I'm just using the rattle gun just to bring it down. So as soon as I started getting a bit of resistance, I basically stopped. And now the pinion is stuck on the shaft. It is a good tight fit on the spline, so I had to... No, didn't want to move. Still didn't want to move. No, can't keep banging it. Out come the puller. Surprisingly, when I did the pinion seal my rear diff, the pinion literally, the flange came off the pinion. But on the front, it is nice and tight. Maybe because it's the amount of K's it's done, it has done very little work. Now, you see I just dropped in there, it's called, it's an oil slinger. That sort of slings you all around. I think it pushes the back away from the pinion seal. Now I've got a brand new pinion seal, which wasn't in the kit. I had to order this separately. Probably should have ordered a spacer separately too, but I didn't. Forgot about it. Making sure the lips of the oil seals are well lubricated, because like I said, it will take a little bit of time for the oil to get up in this area. So gotta make sure it's well lubricated. Now just gently tapping the seal into the housing. Surprisingly enough, this is a genuine oil seal, and the one that came out didn't have rubber on the outside like this one did. But nevertheless, so just gently work it down, make sure it's nice and flat in the housing. This felt a bit better if I used not the hammer directly onto the seal itself. What I am also doing is I'm listening for the sound of the actual, I'm using a socket extension, hitting the actual housing itself, which means it's resting on the housing and the seal will be flush with it. So I'm just working my way around, make sure it's flush all the way around. Just gently working into place. Be careful not to hit the lip seal. It's sort of like a dust seal that would run against the inside of the flange, which would keep dust and dirt away from the actually oil sealing. So I just gently knock it down. Now I ordered a nut and I thought this was the nut for this. Turns out it was not. That was the original nut that I was using, and that doesn't fit. Wrong nut. So I had to put the original back on. Now there is a little flange, like a flange on the nut that you would normally knock down into the slit on the shaft, and I did have to knock that straight. It sort of gives you a line out mark to know where it was originally when the pinion's loaded up. So obviously the wasn't happy with how it went on. Try again. Now it did actually take a bit to get the flange and this bearing to actually seat. So I'm just checking, because I still had marks from when the original bearing nut came off, and I'm pretty much on the marks. Now I'm just checking the preload. Now I found a preload for the bearing, just using a micrometer. Turns out the 3/8 drive one was a little bit, didn't go down far enough. Now happy with the preload, I'll just make my improvised stand up, which was modified out of bits of timber I had lying around. And just using timber text just to hold it down. Now this made assembly a lot easier when you have the diff sitting on something that makes it stable as you're working on it. Just extra one for good measure. Just changing the foot on this one around, just to try and make it a bit more stable. Yes, I did use a semi-lube on the screw. The timber is actually quite thick. It helps get the screw through the first block of timber into the second. Sometimes carpenters use wax, believe it or not, for this purpose. But I don't have wax on hand. I've got semi-lube. And yes, it is an impact wrench with an adapter. It works. So stand back up. Make sure the pinion's still nice and free. That is very important. That it turns not only freely, but smoothly. Now, I have taken the new lock assembly and had the bearings pressed at the workshop, and I have already installed the ring gear. Now, to make it easier to install the ring, it is actually quite a tight fit. And what I ended up using was believe it or not, a pie oven. I put the ring gear into the pie oven for a good 45 minutes, only about, I think it was about 150, 200 degrees. Got quite warm. And it literally slid straight onto the housing with very little effort. Now, this part, I put the locking caps in, and then I put the bearing caps in. Now, even though I had the correct side on the cap on the correct side, one of them did not want to. It kept cross threading on the bearing retainer cap. So the top cap would sit where it wanted to sit, and then the bolt wouldn't go in. So this took a lot of fiddling. So when you come across this situation, you have to be patient, because if you force it, you risk cross-threading and damaging the threads, not on the bearing, only on the bearing cap, but also the bearing carrier. So here I'm just trying to make sure it's in place correctly. Now, it didn't help that the electromagnet locator, which you see on the side there, stops the electromagnet from spinning around and tearing the wire off, was probably putting a little bit of side pressure on the bearing cap as I was trying to install it, which was making things a little bit difficult. Again, making sure the retainers sit in properly. As you see, the other side it went straight on. This side was a mission. I think it was a lot to do with the fact that magnet retainer kept put a bit of side load on the cap as I was trying to install it. Here I am making sure everything's all hunky-dory. Yeah, it's sitting in the bottom half. Yep, making sure I had the right way around. Yes, very painful. Just making sure that the cap actually sat in. Now, I did actually mark the actual retainers themselves, the bearing retainers. So yes, I did put the right one on the right side. Just using the light on the railgun to try and line up the holes. Yep, that bolt went in. Hey, I think we had success. Now just run it down by hand, just to make sure that the bearing cap was lined up correctly. Now, when you got a new center, I'm just trying to set up the dial gauge indicator. Now this is because we have to set backlash, and we have to make sure the backlash is set correctly. Now, before the diff was removed or disassembled, I did take measurements of the backlash of the differential in its original state. Because like I said, this differential has done very little kilometers, even though the car itself had done over 400,000. Because this car is part-time four-wheel drive with freewheeling hubs, this diff had really done bugger all. So I've used it as a baseline. It was well within the specs outlined in the manual, and now we're going to proceed to try and set the backlash on this differential to much the same preload and backlash. So in theory, we should be right. Now this process did take ages. Now when you're checking your backlash, you not only have to try and set up the dial gauge in a way that it doesn't move, but you have to try not turn the pinion at the same time. See there, I just pushed it, and you see the bottom pinion on the bottom's moved. But here I am just checking the backlash, being mindful that the pinion on the bottom's not moving. Now this process did take a considerable amount of time. You'll see me take off the dial gauge, reset it, reposition it. Surprisingly, the marks on the end caps and the bearing retainer did actually nearly line up with the original marks, which means this diff center is actually very close in dimensions to the original diff that came out. Now you see I only did it on one side. I'm just making sure I had a bit of preload on the diff itself, and the cap was actually pushing against the bearing. But you notice I haven't tightened down the caps because you've got to be able to turn them. So now I'm turning on the other side. I'm actually tightening in, so I'm still pushing up against into the bearings. You see I'm still, this one I didn't move very much. Now I'm backing this one off because the backlash was obviously too tight. There is a special tool for turning those caps, and clearly I don't have it, nor was I in. Now if I only backed it off, I should have tightened up the other side, but you see me do it later on the track. I will actually move them in unison a bit more. So I'm resetting up the dial gauge, so I'm still not happy. These things are still new to me, so I'm still learning on how to use it. Now you notice I turned it to the side. I'm actually checking the preload. I couldn't remember if I did this or not. Just making sure that the end caps are actually pushing up against the pinion, the differential carrier bearings. Now that's very important, because once that diff gets put on under load, it will want to move, and the carrier bearings are there to try and hold it straight. So if there's not enough preload on them, the diff will move and will no longer be sitting in mesh. The pinion and ring gear won't be sitting in mesh correctly, and that can result in failure. Apparently the early Prados, the 120 series, the second gen that we got in Australia, the early ones had a known issue with the diff carrier where they would actually flex, and it will result in diff failure under certain loads. So good thing to check for is make sure it is loaded up. Now I've got the backlash set. Now I'm going to see how the mesh is going to mesh. So I'm just using a bit of bluing. Now there is a proper paste you can get. For some reason it was very difficult to get a hold of in Australia at the time. It was either not available or exceedingly expensive. Obscenely expensive. But I was able to find this bluing paste, and it should give us an indication on how they're meshing. Now you see I'm using a block of wood. Now that is to load up the carrier, to provide a bit of resistance, to try and get the gears pushed against each other relatively hard, and if there's any movement you'll see it on the actual bluing paste. So you got to go forward and you got to go back. So you've got two sides of the gear. Now from memory the back side was a bit high from factory, but the forward side seemed to be okay. So here I am just comparing. Like I said, I did actually blue the gear differential before I pulled it apart, and I just want to match it because the backside did appear a little bit high according to the manuals, but the diff originally made no noise, had no issues whatsoever. So as far as my book, if it was good enough before, it'd be good enough afterwards. So again, double check, triple check. This took me ages. And you'll see this not be the first or the last attempt of actually checking it. I will do this multiple times. Like I said, this video is considerably sped up. So we'll lock down the caps. Now it's always a good idea, because the caps weren't exactly buttoned down when we were doing all our checks, but now they're down to spec. We recheck. And yes, it moved, but it turns out I can still turn these caps. Now, because there's a slight change obviously in the backlash. Now it's always an important thing to note, how you set the dial gauge up is very important. Where you've got it sitting can actually alter the reading you get. Some people might think I'm going a little bit pedantic, but this was my first differential and I don't want it blowing up. This took me ages. Like I said, this video only takes 45 minutes. I think I took 2 to 3 hours in total in doing this, making sure I did this right. Now you notice I didn't have the dial gauge on there while I was doing the adjustments, because I believe it would not be good for the equipment to have hammer blows going through it. So again, clean all the bluing off, because things have been adjusted. I'll need to double check and triple check my mesh engagement. Bluing is a very messing stuff. It's like more like a dye than anything else, not like the paste that they normally use for checking your teeth engagement. Very messy stuff. For interesting note, I don't know if you can see it in the video. You might see it in places. You see this like a yellow, white, or even orange staining on the ring gear. That is the original paste they used from the factory back in 1999 when this differential was first assembled. And yes, it was still present. Again, adding a bit of preload, using a block of wood, go in both directions, because we need to check both the front and the back side of the gear for engagement. Now, interesting enough, you put enough bluing dye, it will actually, because there's more teeth on the ring gear than there's on the pinion, it would imprint itself multiple times on the pinion. So I'm just running around and actually having a look on the other times it imprinted itself. And clearly I must have been happy. That white cable there is the actual power, the activation wire that provides power to the electromagnet that locks the differential. Now, I'm not adding more bluing. I'm actually just redistributing what was there. And just double check, triple check. Being very pedantic. I think I needed a bit after this. There it is. See that orange there? That is the original dye, or the paste they use, what's left of it. And yes, it's been cleaned and it still stayed on there. Like I said, this Diff didn't have any issues beforehand, and I doubt if it's going to make any issues now. Again, I'm just going back over my photos, checking my teeth engagement. Checking my backlash. You can never be too sure. Now I'm trying to set it as square as I can get to the tooth, as high as I can get. But it's very important, if you're going to measure it in one way, to try and keep it the same. Again, checking reference photo. So I took a photo of the backlash before this assembly. Again, just making sure I am measuring correctly or incorrectly. Someone obviously commented on one day and say, "Oh, you're doing it wrong." Now I don't have to worry about the rear differential because I've got a brand new diff center to go into the rear housing. Brand new from Toyota themselves. Obviously not happy with the backlash. Again, try and set the gauge in as closely to the same sort of spot. Must have been too tight because I'm actually pushing the differential away from the pinion. And yes, you can have it too tight. What happens is the teeth run too deep. You actually want to run the contact patch to run in the center of the So you're shimming on your pinion denotes where it contacts, where it's towards the edge, near edge, or to the center or back, and the side adjustment moves it in and out of the two. Just making sure. You can never be too sure, because if you get it wrong, worst case scenario, it'll just whine, which you can probably get it put up with in a part-time 4 drive. But in a situation where you need to load that differential up to get yourself out of a situation, if it's not meshed correctly, it could lead to failure. Now these HZJ75s, same as the VDJs later, run a 8.5 front diff center versus the 9.5 in the rear. For some reason, Toyota thought that was a good idea, whereas the older HJ75s and the 47s that preceded it actually run 9.5 front and rear. So here we go, just checking the preload. Now, interesting enough, I had to go down to a 1/4 inch torque wrench just to try and get it to click off. The preload was so slight on the pinion. I think I was getting more on the dust seal or the fucking pinion seal than the actual on against the bearings. So a little bit further. By rights, I should have actually got this down pat a little bit earlier. Like I said, the manuals I had on hand did not provide enough information on it. Didn't even have a procedure for reassembly. So I was sort of flying by the seat of my pants. And surprisingly, it was on the low side. Now, Toyota does actually provide a pretty broad range from preload, and I would imagine with new bearings and that, you want to be a bit on the high side to that. But it was on the low side, and you see I'm going both ways here, just making sure that the preload's the same. Yes, this torque wrench can actually go in both directions. My 1/2 inch can't do it, but this one can. Same as my 3/8 drive, that can go both directions too. So here I am just adjusting backwards and forth, trying to find where it's clicking off to try and tell me. So I am actually driving forward. So this is the direction of travel. This is a high pinion center. So the pinion is above the center line of the differential itself. Hence why it needs all the special oil galleries. You see on the side there's actually a little intercast in the housing where it actually catches oil, and then it will run down into the bearing area. You won't find that on a low pinion, because in a low pinion the oil's just about sitting where the pinion is anyway. But in high pinion it's sitting out of the oil, so it needs these sort of oil passages. And surprisingly, it still stayed at low end, and I actually did go past where the mark was. So actually, that crush tube would have got crushed even further. So did I need to replace it? Not really. Should I replace it? Yeah, could I? Again, check the backlash, because I have changed something. So if the backlash hasn't changed much, we know that the pinion was pretty much sitting where it was needed to sit anyway. And because we hadn't actually changed the diff center itself, oh no, did change it. I'm not happy. Like I said, this took me ages. got to tighten up the other side to match. Like I said, surprisingly, they nearly lined up on the marks that I did before disassembly on both sides. So I'm pretty confident that it is set correctly, or as best as I'm going to get it anyway, with my lack of experience. So obviously it's still a little bit on the tight side. Obviously I got a little bit lazy, left the dial gauge on there. Obviously I wasn't shaking it around too much. Gone a little bit too far. This is not ideal, knocking them like that, but like I said, I didn't have the correct tool on hand. Again, because we have made changes, obviously we tightened the pinion up, which I probably should have done to begin with, so I wouldn't have to do this 3 times, 4 times, lost count. But like I said, this was a learning exercise for me. This was brand new, never done this before. Couldn't feel any preload, or lack of preload on the pinion, on the carrier bearings. Now, differential specialists would have probably had this done in a half an hour, or done the whole job in under an hour, including swapping over the pin ring gear and from centre to centre. But that way, I also would have had all the proper tools, and they would have had experience that I didn't have. Now that I'm happy on the setup, these locking pawls will go in. So these are to ensure that the bearing retainers don't move, because you don't want them moving, because if they come undone, or your preload will come off your differential, and therefore the teeth aren't meshing correctly, and some very bad things can happen. So just making sure everything's all honky-dory. Check the preload. Like I said, very surprising, very low on the pinion. Even though the pinion nut was actually done up past, probably about an 1/8 of the turn past where it was originally. So it actually has pushed against that cross tube a bit more. It is still on the low side. Now that I'm confident that things are now where they should be, now I'll tighten them down. Could have actually used a little bit of Loctite, but originally didn't have them in there, so I don't think I didn't feel it to be necessary. Now, interesting enough, the Diff center, as you see what the little green marks are, on the factory Diff, they don't use Loctite. They have locking tabs, but because the bolts sit recessed into the carrier, you can't use them. So I had to use Loctite on these bearings. Now, one annoying thing about this install, they're very vague on where or how to run that wire, or where to put the hole. They're exceedingly vague. But then I could not push the grommet down far enough to able to get the wires through far enough. So you would have seen me use a knife to really peel back on the heat shrink that he used. Now I'm trying to get hold of it. Now you've got to be very gentle. You don't want to damage the wire because this is the activation wire. Now I'm trying to pull it through and get the grommet through at the same time. That's probably what I'm actually hanging on to, is the actual end of the grommet itself, and I'm pulling it into the housing as far as I can, making sure it's seated. Now you can see the end of the wire is just sticking past there. Now, interesting enough, it doesn't matter on the polarity on the coil. So there's no positive and negative markings on the wire, or as long as you've got power going through it, it doesn't matter. So here I am just making sure the wire is secured, because the last thing you want this thing is to make contact with anything spinning inside the differential, which would be bad. Now I have heard some horror stories about the locking tabs on the side, because they're only sort of TIG welded to the side of the electromagnet, and I have heard of them in certain situations snapping off, which leads to the whole thing to spin around and tear that wire off, which leads to a inoperable locker. Diff still works, but locker doesn't. Another annoying thing about the instructions is total lack on how to actually fit the connector. Turns out it had two blanking grommets in them that you had to remove, and it's not in the instructions, because on some connectors they actually are hollow in the center, so you can actually push through it and acts as a seal. No, you actually take them out. That was fun, because I managed to push one in enough that I had to use a special tool to get it out. And one of them didn't want to seat properly either. It took numerous attempts to get it to actually seat. Because if you don't get them to seat properly, what will happen is when you plug it into the other connector on the harness, the pin that's not seated correctly would most likely push back out of the housing. So you end up with either not a good enough connection electrically, or in the intermittent one. Or if it does actually work, it'd be high impedance and could actually ultimately heat the connector up and melt it. So again, check. Like I said, I'm not a professional. That would have definitely a sequence in doing this thing properly. I didn't. But it's back together, and thank you for watching. Until next time.